Started up my laptop screen, ready for the Python scene. All those lines of text so clean, let's code and chase that dream. Python world, here we go. Write the script, let it flow.
In this video, we're going to learn how we can raise our own exceptions in Python. So we're not limited to just waiting for exceptions to be raised by built-in functions or operations that may trigger them in an error condition. Instead, we can also manually raise our own exceptions. We accomplish this using the raise keyword and by specifying a specific exception type and optionally a message to provide that exception. Usually when we raise an exception, we want to provide a message to explain what the error condition is that occurred. So the syntax for this raise keyword is pretty straightforward. It's raise, the name of the exception type, and then optionally an error message. And that would be a string value. If we don't want to provide the error message, we simply leave that part out, but we still include those parentheses. So the exception type would be shown here in red. We'd replace that with whatever exception type we're trying to raise. For example, a value error, or maybe a file not found error. And as I said, the optional error message would be a string value. Let's take a look at an example. This is a fairly straightforward example where we're asking the user to input their age. And in this case, if their age is less than 0, which shouldn't be possible, we're going to raise a value error. And the message contained in that value error is going to be age cannot be negative. If we were to try to run this in Python and we input -1 into the console, we would get a traceback like this that says there is a value error, and the message contained in that error would be age cannot be negative, which we can see in that traceback. So setting these error messages can be really helpful because it makes it far easier to debug the code and to explain to the user of the code what went wrong. So to quickly summarize, the raise keyword raises an exception manually. In this example, if age was less than 0, we tell Python to raise a value error. If this value error is never caught with a try except block, then it causes the program to terminate and a traceback to be printed. Let's take a look at a more interesting example that involves withdrawing funds from an account. Here we have a function called withdraw, and it takes an account, a name, and an amount. The account would be a dictionary that defines all the different users of the system, as well as their current account balances. Name would be the username who's withdrawing money, and amount would be the amount to withdraw. The account dictionary is set up such that each key in the account dictionary is a username, and each value is the amount currently in that user's account. Now, there are a few things that can go wrong in this function. For example, the name we specify might not be in our account dictionary. Another possibility is we try to withdraw an amount, but they don't have enough in their account. So we need to account for those and raise an exception when they occur. The first one is if the name is not in the account dictionary. So we're going to use the not in operation. We're going to see if the name is not in the account dictionary, then we're going to raise a key error. This is going to say no account for name was found, where name is going to be replaced with the actual name provided to the function. The second error condition we need to check for if the account dictionary does not have enough money listed for that user. So we look up the current amount in that user's account using account dict subscript name, and then we subtract the amount from it. If that's less than 0, we know they don't have enough money to withdraw. In that case, we raise a value error, and that's going to contain the message withdraw would make the account negative. So let's switch over to PyCharm now and try out this code in debug mode. Okay, we're in PyCharm and we have the example loaded up. This part of the code right here is all the withdraw function. Here we're defining our accounts dictionary with a few different users, Alice, Bob, Chuck, and Dave, and we're starting them off with different account balances. Then we're going to ask the user to input their name, and we store that in account name, and we're going to ask them the amount to withdraw, which is going to be a floating point value, and we store that in withdraw amount. Then we're going to call our withdraw function. We're going to provide it the dictionary, we're going to provide it the account name, and we're going to provide it with the withdraw amount. So our withdraw function doesn't return any values. Instead, it just makes changes to our account dictionary directly. Because dictionaries in Python are immutable, that means if we make a change in the function to that dictionary, such as updating a key value, that means it's going to be reflected outside of the code. After we do the withdrawal, we're then going to try to output amount left and say how much is left. Inside the function, we have the checks that we just discussed that are our error conditions, and we're going to raise an exception in those cases. And if those exceptions don't occur, then we're going to withdraw the amount by simply subtracting it from the current value in the dictionary. And we're also going to output to the terminal how much we withdrew. Then we're going to exit the function. So let's try this with a few different values. We could start with something valid. So let's start with Alice. And let's say we want to withdraw $1. Alice should have enough money for that. And we can see withdrew $1 and the amount left is $1 or $2.50, which is correct. And now let's add a breakpoint to that right here. And we will run this in debug mode. Okay, we've run this in debug mode, and now we're going to try to inputting some values. In this case, we're going to try to trigger this error case where the account name is not found. So we have Alice, Bob, Chuck, and Dave in our dictionary. So we're going to input a name that's not in our dictionary. In this case, Eve. And we're also going to put an amount to withdraw. In this case, it doesn't matter since it's going to have an exception before that. Okay, we've made it to the breakpoint, so we paused, and we're going to manually step into the function. We've entered the function. We can see we have the account dictionary, and there is no Eve in it. Our name is Eve. So we're going to check, is Eve not in the account dictionary? It's not. We can see down here that we only have Alice, Bob, Chuck, and Dave. That means this is going to return true, and it means we're going to enter this if statement. We are going to raise a key error with the text, no account for Eve was found. So we've generated that exception. And what's going to happen is this exception is going to be raised. There's no code in here to handle the exception. There's no try except block. So it's going to propagate outside of this function and return back to here. But since, again, there's no try block to handle that error, this means that the exception is going to terminate the program, and it's going to give us a trace back explaining what happened. And we can see that happened. And you'll notice in the trace back now, we have a little bit more information. The reason why is because we had a call stack of different functions. So it explains in the traceback how the code went through each one of those functions and how the exception propagated back through the call stack. So in this case, it's saying that the withdraw function had the exception, and it happened due to this line, which was manually raising the key error. We get the type of the exception, key error, which is what we defined up here, and the message contained in that exception. No account for Eve was found. So it seemed to work correctly. We did raise an error, and it caused the program to terminate. So we're going to run it again. In this case, we're going to put in a valid name, maybe Dave. But this time, we're going to put in too much to withdraw. So we'll put $10, which would be more than Dave has. So it paused at our breakpoint. We go in now. Dave is in the dictionary, so this returns false. We go to the next line. Now we're going to retrieve the value at the account name, Dave. And that's going to be equal to 0.56. And we're going to subtract the amount, which was 10. So this would result in a negative number, which is less than 0. So this would be true, and we're going to trigger this next raise line. So we enter the if statement, and now we're going to raise a value error exception, and the text is going to be withdraw would make account negative. The exception's generated, and now the program's going to terminate because we're not handling the exception anywhere. So we get a traceback. Again, it says it happened in the withdraw function, and we get a value error. And it says the type of the error was value error, and the text was withdraw would make your account negative. So at this point, the code's working, but it's not really helpful because we're raising exceptions, but we're not handling those exceptions. So if we want to handle those exceptions, we would need to use a try except block. And it's fine not to do it in the function. It's actually a little bit more useful if the function raises exceptions rather than tries to handle them, because this lets the calling code figure out what to do. And that's often preferable because the calling code has a little bit more information, a little more context about why it was being called. So to handle this exception, we're going to need to add a try except block. Now remember, like we discussed in the last video, it's best practice to only put code that can generate the exception in the try block. And first, we're going to handle the value error. And we're going to call that VE. And we're going to print out count balance. error, and then we'll include the actual exception message. So this would handle cases where the account would go negative. And the other error that could be generated was a key error. And that would be if the account name isn't in the dictionary. Now, the other thing we have down here is we're outputting the amount left. But this would be a problem, for example, if a key error happened, because we'd be trying to withdraw or output the value rather from an account that doesn't exist. And this would probably cause its own exception if we did that. So what we're going to do is we're going to wrap that in an else part of our try except statement. And if you remember, else is only run if no exceptions occur. So if there's no value error, there's no key error, then we're going to run this print statement where we say how much is left. So let's give this a run and see what happens. So we're going to try putting an invalid name. There's no Dan in the dictionary, so we'll see what happens. It doesn't really matter the amount. Try that out. And we get an account error, or account name error. No account for Dan was found. And this no account for Dan was found is coming from the text of the exception we raised. We're outputting that here with VE. When we send an exception object to print, it turns it into a string, and then it outputs the message contained in that exception. The other type of error we can get is that key error, so let's try doing that. Let's see who we have up here. So let's say we go to Bob, and we try to withdraw $50, which is too much because Bob doesn't have $50 in this account. We can see withdraw would make account negative. And it was an account balance error, which means it was handled by this part. Last thing we'll do is we'll try to run it without any errors. Here we'll try with Chuck, and we'll withdraw $1,000 from Chuck's account, which he should have more than enough. We got withdrew $1,000, amount left $337.32. So raising exceptions like this can be really powerful because it allows us to denote to the caller of a function when something has gone wrong. And usually the caller of the function would be in a better place to resolve that error. For example, instead of just adding a try except block like this, we could also contain this input here in a loop. Let's try doing that. So we could say while true. We're going to ask them for input, and only if it was successful are we going to break out of that loop. So by simply adding while true up there and a break here, that means this is going to keep asking them for input until they input valid values, and then we break out. So if we put something invalid, what's a fake name we could use? Do Sam, some amount. You can see we get an account error. No account for Sam was found, and it allows us to input it again. So we could say Dave, $10, which would be too much. Balance, and it lets us input it again. And now we can do a valid amount for Alice, $3, and it finally exits. So the caller of this function was better suited to dealing with the error because it could ask the user for the input again. This is why it's great to raise exceptions rather than try to handle them all in our own function if we can't do that in a meaningful way. Let's switch back to the slides and quickly review what we looked at here. And we're back. And in the slides, you can also find a copy of some of those outputs for your reference. Now, I also showed that example of where we added the try except block. This copy doesn't have that while loop yet, but it's fairly easy to add. But let's just review how this works and how we flow through this code. So in this case, we have the try block, which means we are only going to be looking for exceptions in this called the withdraw method. Next, we're dealing with any key errors. Next, we're dealing with any value errors. And lastly, this is the code that's going to be run in this else block if there were no exceptions, which is just printing the amount out. So for example, if our input was Jack and we tried to withdraw 75, this is going to be a problem because there's no Jack in the dictionary. So we can see what would happen is we would raise an error from the exception, key error in this case, and that would be raised from the withdraw function. This would then cause execution to jump back. We don't run the rest of the function, so we don't get that withdraw print. And it would then land in the try block, where we called withdraw from. The exception would propagate down there, and in this case, we would capture it in this try except block because we are looking for key errors. And it would cause account name error and then the message stored in the exception to be printed. If we tried running it with Chuck, which is a person in the dictionary, but we gave it an amount that's too much, it would cause the account to become negative, we're going to get a different exception, a value error. So in this case, we raise a value error. Again, that gets propagated outside of the function and down into the try block where we call it. The try block deals with this exception because we listed that it handles a value error. We then output account balance error and the message contained in the exception. The last possibility is that there was no error. For example, maybe we input Alice and a withdrawal of $1.25, which she has more than enough for. This would cause us to get to the end of the function, and the function would return as normal. It would print out the withdrawal amount, and then it would continue on from where it was called, which was in the try block. The try block would finish, and then we would go to the else block because no exceptions were called, and then we would print out the amount left. Now we should talk a little bit more about how exceptions propagate through function calls. So any exceptions that aren't handled with the try except block keep moving up the call stack until it eventually reaches the caller. What we mean by that is if you have a chain of functions where one function calls another function that calls another function, exceptions are going to keep going down or up the call stack, depending on how you see it, until it reaches either the end of the program and it causes the program to terminate or crash, or it is eventually handled with the try except statement. That can sound a little bit complicated, so let's take a look at an example. So in this example, this doesn't really do anything useful. It's just sort of an example to show how this call stack works. We have three functions, function 1, function 2, and function 3. This code is going to call function 1 to start with, which means that it's going to start at this try block here that's defined inside function 1. Inside this try block, the first line is to print out in func1 calling func2. So in the terminal, we get in func1 calling function 2. We then continue on in the try block, and we get to the call to function 2. This causes function 2 to execute, and we start at the first line of function 2, which is going to be simply printing out in func2 calling func3. We then proceed to the next line, which is a call to function 3, and then we're going to call function 3, print the first line, that's the first command, which is going to say in func3 about to raise an exception. Now this is where it gets more interesting. In function 3, we have raise value error, an exception, or an error occurred in func3. And this is going to call that exception to propagate outwards up the call stack. So it's going to go back for each function we called until it's either handled eventually or gets back to the start, and then it will cause the program to terminate. So let's see what happens in this case. So we call raise, and we raise an exception. This exception propagates outward to where we called it in function 2. Now notice here, because it's an exception, it means we're going to break out of this function right away. We're not going to go to the next line because this exception isn't handled. Because function 2 doesn't handle the exception, it means it's going to propagate to the next function that called it. In this case, that would be function 1, where we called it from here, where it says function 2. In this case, it's a bit different though, because this is contained in the try except block, and we are handling the exception type that we're raising here, which is a value error. So because we're handling that, it's going to enter the exception block and call this line down here, which says in function 1, caught exception from function 2. And it's going to output the message of that exception. Then finally, since this function is done, function 1, we would resume code right here after our call to function 1. So this may seem a bit complicated, but keep in mind exceptions always propagate outwards along the same chain of function calls that we made to get there. If we don't handle that exception at any point, it will eventually cause the program to terminate and print out a traceback. If we do handle it, it will be handled by the first try except block that deals with that exception type. Now we're going to go over a few best practices for when we're propagating exceptions like this. And the first one is we should let exceptions propagate if the function can't meaningfully handle that exception. A common error people that are new to exceptions make is try to handle every single possible exception they can, even if there isn't a meaningful thing you can do to resolve that error. Often letting the function raise the exception and propagate it to the caller means that the caller will have more context about what went wrong and have more ability to resolve that. For example, in the example we saw in PyCharm, we added a while loop outside the function, and we could ask the user for new input. That wouldn't be possible inside the function, so if we did that in the function, we wouldn't have a meaningful way to correct the error. We wouldn't have a great way to ask the user for a new name. The next tip is to always ensure that resources are properly released before we propagate any exceptions. So if we have a function that's reading from a file, we should ensure that that file is closed before we raise an exception. Now, one way to do that would be with that with statement that we saw in a previous video that always ensures that the file is closed. Lastly, we should know what exceptions a function you're calling can raise. If these are our own functions, then it's pretty easy. We just look at the code. But if it's something built into function or our third-party library, we should always take a look at the documentation to see under what conditions an exception can be raised to know if we should be trying to catch those exceptions with the try except block. So one scenario you might find yourself in is maybe you've written a function to process a file, and something goes wrong in that processing code. Maybe you read in something that should be an integer, but it was something else like a string. And you surrounded your code in a try except block to try to capture anything that could go wrong and then clean up. Maybe you need to close the file, for example. Now, the issue is, if you've handled that exception and you've closed the file, how are you going to communicate that onwards to the caller of your function? Now, we could raise a new exception using the raise keyword and say the exception's type and then the message. But the issue with that is it's going to lose some information in that exception object, because that would create a new exception. That means it wouldn't have the same traceback information, it wouldn't have the history of where it came from and all the functions it propagated through. So to raise the same exception rather than creating a new one, what we can do is use the raise keyword without any arguments, just raise. If we do that in an except block, it is going to propagate the same exception that it was already handling. That may seem useless, but it means that we could do things like close the file before raising the exception to signal whoever called our function that something went wrong. That sounds a bit complicated, so let's take a look at an example. What this example does is it tries to process a configuration file. If the file exists, it simply reads the configuration file and returns the data in that file. Now, what's more interesting in this case is if the file does not exist. In that case, it handles the exception by using a try except block and looking for a file not found error, and then it creates a default configuration file. So it'll create the file, and it will fill it with some default settings. And then the key thing here is we re-raise the exception. Calling raise here without any arguments causes the same exception that already occurred, in this case it would be a file not found error exception, to be raised again and propagate outside of this function call to the code that called it. At the bottom of the file here, we have the code that's actually calling our process file function. And it's passing it something very simple, which is just a file name called config. Let's pretend that this file doesn't exist yet. So calling this would cause our function to execute, and it would start with the try except block. It would enter the try block and run the first line. And that first line is this with statement that's going to attempt to open the file. Now, in this case, we said the file doesn't exist yet, so this would raise an exception. That exception would be the file not found error exception. That means we'd immediately enter this except block, and inside this except block, we have another with statement that's going to create a new file, the one that's missing, and fill it with some default values. Remember, these with statements handle closing the file for us, so we don't have to worry about that. In this case, it's going to close the file, whether there's an exception in it or not. Then we're going to get eventually to this raise statement. This causes us to raise the same exception that happened. So that means we're going to raise the file not found error that was created by the open function, and that is going to propagate onwards to the caller of this function. In this case, the caller of the function was this try block outside of the function, which is going to try to call the function, and if a file not found error occurs, it is going to execute this except block at the end. All that's in this except block is a simple print statement that says error, a default configuration file was created because the file was missing, and then it prints out the text contained in that exception. So we can see that output at the top of the screen now, and we can see the text contained was error2, no such file or directory, config.txt. So after we ran this, it did create a file, and that file would have two lines, setting 1 and setting 2, equals default value 1, default value 2. This is just sort of a silly example. It's not doing anything meaningful. But if this was a real configuration file, we'd want to fill it with meaningful defaults. Now, the second time we run this program, something different will happen because config.txt now exists. So when we run it a second time, we're going to get configuration file successfully read. The reason why is we're going to call the process file function, and that's going to eventually execute the with open block. It's going to open the file for reading. It's going to read all the data into data and return. So the file actually exists now. No file not found error exception will be raised. So we just get the text configuration file successfully read. So combining try except blocks and the raise keyword can be quite powerful. We did something that might seem quite complicated here. We checked if the file existed and created a default file if it did not. In our previous video on handling exceptions, we ended with some tips and best practices for handling exceptions. So in this video on raising exceptions, we're going to end in the same way and give some tips and best practices for raising exceptions. Our first tip is to be purposeful while raising exceptions. We should never use a try except block or a raise keyword to replace the normal control flow or logic of our program, meaning we should never be replacing loops or if statements with exceptions. We should only be using exceptions to signal that an error occurred, and it should be one that it would be hard to handle otherwise. The second tip is to use specific exception types. And this is similar to some of the tips we covered when we're talking about handling exceptions. We should always choose a built-in exception that accurately represents the error condition. For example, we might use a value error to represent that there's some sort of issue with the value that was input to a function. And we might use a type error to signal that the type of the argument sent into a function was the wrong type. We always want to be careful that we're using the correct exception type, because Python won't be able to detect that you use, for example, a type error to describe like an index error or something like that. The next tip is to provide clear error messages. We should always include an error message in our exceptions, and they should be meaningful so that the user of the program can understand them. Next, we want to re-raise exceptions properly. If you catch an exception but want it to propagate, use raise without arguments to preserve the original traceback information encoded in that exception. We never want to replace the exception with a new one because that means we're going to lose some of that traceback information. And lastly, we want to avoid side effects in messages. So don't perform operations that alter the program state when we're creating an exception message. That's all I have for you in this video. I highly recommend that you try out some of the examples to get an idea of how these exceptions propagate. A good one to try would be example 8.6. Maybe try putting the try except block somewhere else to see how those exceptions propagate through those 3 function calls. Thank you for watching and have a great day.